Okay, guys, recording the vodcast for Lab 3.3P, like dissolves like. For this lab, since it was one where there were many observations you had to take with respect to polar and nonpolar substances, I chose randomly a group's lab report, and I'll just go over it. I chose theirs because it represents one that would receive a perfect score. So we're going into the chart, and for their water test, we noticed that the crayon did not dissolve at all, but they really had a clear dissolving of the washable marker with water. Permanent marker isn't showing much, probably because it's been sitting around for a while right now. They noted that it does not dissolve, they noted that it does dissolve, and they noticed that it semi-dissolves. They probably saw a little bit. Actually, if you look up here in the corner, you can see somewhat some remnants of dissolving. With the paint thinner, we saw dissolving here with the crayon. You can notice that it's blurred out right here. Nothing happened with the washable marker. That's a huge observation. And it semi-dissolved, they said again, with the permanent marker. Looks like there's a little bit more up here with the water testing. Either way, this is a good chart. For the first question up here, they just went through and repeated what I said. They said like dissolves like. That means that polar solutes dissolve, polar solutes dissolve polar solvents, and nonpolar solutes dissolve nonpolar solvents. Perfectly fine there. Water, the Lewis structure shown in the bent conformation. It is polar, and it's polar due to the central atom has lone pairs. I would actually go on to say, thus making the molecule asymmetric. Lewis structures drawn here for paint thinner, acetone, and see no lone pairs on any central atom. Nonpolar, no lone pairs. If you look again, there's a central atom there and there, and we don't see any lone pairs. So let's go to analyze our results. We saw that the nonpolar solute did dissolve in the crayon. So because like dissolves like, the crayon must be nonpolar as well. Because the water, which is the polar substance, that dissolved in the washable marker, and because like dissolves like, the washable marker must have been the most polar. With respect to their answer to why water has a higher boiling point than acetone, they do a really good job referring to the intermolecular attractions because we're talking about boiling point. And they just go on to say water's intermolecular attraction determine that its boiling point is high in the presence of hydrogen bonding. There's the intermolecular attraction that they noted. Acetone's intermolecular attraction is a London force, often called a van der Waals force as well. And thus, acetone has a low boiling point. Really good answer. This question, I'm getting you guys thinking about vapor pressure, which is always opposite of boiling point. And I like this one. It says, since water has a hydrogen bond, it's actually hydrogen bonds. It's got two of them. It has a low vapor pressure, resulting in no odor. Acetone, having London forces, has a high vapor pressure, resulting in a distinct scent. This last problem is a very classic AP free response problem. They give you two compounds, hexane and ethanol, and they ask you which one is soluble in carbon tetrachloride, which is CCl4. Well, this is going to be a strict like dissolves like problem. First, draw out the Lewis structure for hexane. We see that on every central atom there is no lone pair. We draw it out for ethanol, and we see in the central atom here we have some lone pairs pushing it into an asymmetric position. Now, this is going to be a dipole-dipole interaction because there are no hydrogen bonds. There are hydrogens, but they're not connected to the oxygens. Now, there's carbon tetrachloride. Although there is a bunch of lone pairs, none of them are in the central atom. So this molecule is nonpolar. This is nonpolar, Hexane's nonpolar, so hexane should be soluble in the CCl4. Let's see if they said that. They said hexane is not a nonpolar solute that will dissolve in nonpolar solvents. Okay, like carbon tetrachloride. So really good answer. Take care, guys. Have a good day.